Hello, everyone. Today, we will explore relations and functions. This chapter delves into the fundamental concepts and properties of relations and functions. First, we introduce binary relations, which are subsets of the Cartesian product of two sets. A binary relation allows us to connect elements from one set to another. The chapter emphasizes the importance of properties of relations, including reflexivity, symmetry, antisymmetry, and transitivity. Reflexivity states for every element A in the domain A is related to itself. Symmetry states for every element A and B in the domain, if A is related to B, then B is related to A. Antisymmetry states for every element A and B in the domain, if A is related to B and B is related to A, then A equals B. Transitivity states for every element A, B, and C in the domain, if A is related to B and B is related to C, then A is related to C. These properties help us classify relations and understand their behavior in different contexts. An equivalence relation is one that is reflexive, symmetric, and transitive, allowing us to partition sets into equivalence classes. A partial order relations satisfy reflexivity, antisymmetry, and transitivity. Lastly, we discussed about functions. A function f from a set A to a set B is a relation that associates each element of A with exactly one element of B. The set A is called the domain, and B is called the codomain. A function f is one-to-one or injective if distinct elements of the domain are associated with distinct elements of the codomain. A function f is onto or surjective if every element of the codomain is associated with at least one element of the domain. In other words, for every y in the codomain, there exists an x in the domain. A function that is both one-to-one and onto is called a bijection or a one-to-one correspondence. A bijection establishes a pairing between the elements of the domain and the codomain. The composition of two functions f and g, denoted g compose f, is defined by g of f of x for all x in domain of f. The domain of g of f is the domain of f, and the codomain is the codomain of g. The inverse function can be obtained by interchanging the first and second coordinates of each ordered pair in the graph of f. If f is not a bijection, then f inverse is not a function, but it's still a relation. Thank you and goodbye.